Hello. It looks like you can hear me. Okay, today we're going to continue with exception. So now you will start to see how the exception mechanism from the theory that we talked about last Thursday into practice. And how do we really implement exception in a system such as your homework assignment number 3 today. So let me just review 2 slides to kind of refresh our memory from last Thursday about what's the important point. The first thing is we have a 3 new keyword, which is try, catch, and throw. So try define a block of code that we try to catch any kind of exception that will handling either directly from the first layer of code or involving some of the function being called by this layer of code. All right, and that's try. That kind of define the scope about what region of code we would like to catch. And then after we catch it, then we're going to have another block of code, which is defined as the catch clause. So catch looks like is a function, which basically say if there is any exception that was detected in that block of code defined by the try, then depending on what kind of exception, by the way, what is an exception? Exception itself is really an object. So exception is an object, and that object has a type. So essentially, we're trying to see is that, well, if I realize somebody throw an object within that block of code, either directly or indirectly. Okay, indirectly means that the code doesn't have any throw statement, but one of the function that is included in the scope that will have the throw statement, then that counts. So when you throw, it must throw an object. Any object must have a type. So essentially, the catch will try to catch the type of exception, the object that's actually either matching the catch or is a derived class of this class. Okay, so you could catch exactly, say you're catching a integer. And then you actually has a throw about integer, yeah, you match that. But sometimes if you try to catch a GPS location, but then the throw is throwing a label the GPS location, which is the derived class, then this one will work. So basically, the catch clause, the object here, need to be exactly matching the type, or in some case, it could be the base class. No, sorry. It needs to be the derived class of the object you try to throw. Okay, so that's the difference. So essentially, this is interesting. I should probably write it down. So if you have I hope I'm getting this right. Okay, there's only 2 ways to say this, and one way is definitely wrong. I hope I'm in good spirit today. All right. So if you throw, let me move it here. If you throw a derived class, let me see. Just make sure let me see. If I throw a base class, okay, yeah. If you throw a base class, and you can catch with a derived. Okay, so let me give you an example of this. If you throw, oh no, it's the other way around. See, I know my spirit was not so sure. If you throw a derived class, you can catch with a base class. So for example, if you throw a, no, I got it wrong. See, this is hard for me. Is that right? What was my example? Let me hold on. Let me take a look at my example. So this is Memorial Day weekend was probably I'm using Memorial Day as an excuse. Let me see. Do I have that example? Okay, let me do it this way. So this way I can explain myself clearly. So I actually have two exceptional class. One is I call STD exception. Let me use a new slide. This, okay, one of the class is STD exception. Okay, and then the derived is ecs36b exception. Okay, so STD exception is the base, and ecs36b exception is the derived. Okay, so if I throw, so the case number one is that if I throw STD exception, can I catch it with ecs36b exception? Or the other case is you actually throw a ecs36b exception, but can you catch with STD exception? So this should be here. So you can see that I have a pair of base and derived class. So I have two cases. Let me actually put this in here so you will know the outline. I have two cases. So now my question to you is that let's just do a guess. First let's understand this example. So somewhere in your try clause that you throw a base. Essentially, this is saying that you throw a base, and then you can catch with a derived. That's case number one. Case number two is that you actually throw a derived, and you can catch with the base. So that's basically catch and throw. They are matching with the type. If the type are identical, we don't have an issue. But with inheritance, now we have these two cases. And I want to tell you that this is not possible. This one is wrong. This is wrong. And this is okay. Okay? So you can throw a derived class and let the base catch it. But you cannot throw a base and let the derived catch it. Okay, think about that. We will see some proven example. So that's the relationship between the throw and catch. Okay, over here. Yeah, that's what I wrote here. That's correct. You can throw the derived and catch with the base. Okay, so that's a little bit tricky about not just type matching, but look at the inheritance relationship. Okay. All right. Any question with this slide? This slide just want to tell you this is three different new keywords we introduced in the language. Try, throw, and catch. All right. All right. So then we talk about this slide. This slide is kind of interesting. I kind of redraw this slide a little bit. This is basically say, hey, the throw and catch is not just happening one level, but happening multiple levels. And sometimes the exception need to be aggregate. This was probably the most challenging concept. I kind of tell you, if I show you the previous slide, you're thinking it's just a one pair. Okay, you throw, I catch like a baseball, but it's a systematic. Okay, it's almost like somebody catch it and somebody throw it again to another base and things like that. So this is kind of what we call the layer of exception. So I want to give you this example. This is, by the way, it's not the most complicated one. We'll see something which is much more complicated than this, but this is already good enough to illustrate the challenge that we need to deal with when we write the exceptional handling as a system to work together for your program. Okay, so essentially what you have is that, by the way, let's first look at the function. The high-level function is f main. F main call f upper, okay? F main call another function called f upper. And f upper inside is going to call both f1 and f2. They call two separate functions. And then we have f1 and f2 on the left-hand side. Okay, so we have four functions involved. F main call f upper call f1 and f2. So many places of the code, within this four function, you might have exception that you want to detect it and reflect it in the exceptional handling. So I simplified this already. It's saying that, okay, only f1 and f2 has detection mechanism, that they actually have some logic they need to detect and such that they will be able to throw exception. Okay, so you can see that F1 and F2 has a try and catch clause, has try and catch. So F1 is designed, I try something and I catch something, and then I actually throw something over here. Okay, so when the catch, within the catch, it has another throw. So this is a second concept. For the same function, you catch something, you can throw another one. So when you throw, you can actually throw exactly whatever you receive as a catch, but you can actually add more information and you can actually do a lot of other things. You might throw a different type of object. Okay, I mean, that's why this is important to tell you about this. So for example, I said this is okay. So you can throw a derive, but then you catch with the standard exception. So when you catch the standard exception, you want to rethrow, you can rethrow standard exception. But you could also do it in the program that you can detect that, wait a minute, this is not the base I want to throw. I want to throw a derive. So you actually regenerate the derive and throw derive here as well. So you might actually catch a base, but you throw a derive in this context. Okay, you can do pretty much anything to fit the requirement that why you need to throw it that way, which you will see some real example I extended from your homework assignment number 3. Okay, so you can see that F1 rethrow, and that will be catched by F upper. F upper, I kind of have a bunch of routine. I have a try catch over here. So F upper, I actually got the E object. So the important thing is I actually accumulate. So the reason I have this F upper here is that I will be able to accumulate all the exceptional condition, including in this example, both F1 and F2. And I want to include them together as one single exception object, and I throw that one to the main. So you can see that it's not just one-to-one, but it's a multiple to one. And sometimes it's one to multiple as well. So essentially, this exception mechanism, in this example, it has the capability that aggregate all kind of error that I have in the execution of this program, and then put one single exception into the main program. So now the main program, after he finished the whole thing, it will be able to just basically process all the exception from generated exceptions, plural, from both F1 and F2, and they need to do that. Okay, so that's kind of a more complete way about using the exceptional handling. So you can think about your assistant will getting more and more complicated, and it's kind of not good enough for you to just respond to the first exception you detected. Sometimes it makes more sense for you to understand the global view about all your exception and decide how you're going to deal with that. And by the way, sometimes we'll think about exception is an error, but sometimes not. Sometimes exception is just another way of reflecting the dynamics or uncertainty about your system. So sometimes you look at this, if you only reacting to one particular exception, you might not have information to properly handle that exception, which I will show you an example, maybe not this lecture, but sometimes you need to see all the exception and decide what will be the most appropriate way to respond to all the exception as a systematic. Okay. Okay, any question with this slide? Okay, it's just theory. You probably the first time you look at this, you probably have no feeling and no passion about this. No worry. Let's look into the code. Okay. All right, I'm going to reverse something back. Okay, I'm using homework assignment number 3, ref3 as an example. Okay, first I want to, I did some kind of hacking, so I want to change it back. I think I did something with, let me look at the timestamp. So I know what I did, change. Okay, so I need to change, I change person, time, GPS record, and I change, I believe, I changed both client and server about the ref client server. Okay, so now let's actually change it back first before I actually try to run it. Let me first change back the time personal time.cpp. What did I change? I think all I did is shadow record. This change is actually minor. What I did is I actually print out the result. Okay, when I make the call to the remote, my client.upload within personal time GPS record, I actually add the printf statement, which is the CR. Okay, so I'm not going to change back. This is harmless. Okay, what I did need to change, I know what I need to change. I'm going to change this server, hw3ref3 server. Yeah, I did some major changes here. Upload. Okay, over here, let me tell you what I did. I actually add the exceptional handling right over here. You see that initially it was just this line of code. Okay, let me tell you that this 2 lines of code was original. But I actually add a bunch of things, which is a try and a clause. I'm going to first comment that out everywhere. Okay. The other thing which I change is the client. But I think I might not need to change this part because let me tell you what I did is that I have this code, which is now is under this if that block EE, which I basically check everything, make sure the JSON, the format, everything is there. But now I'm going to block it because I'm expecting the server to check it. By the way, I'm not sure you realize this. In the reference implementation of hw3 ref3, I basically did the JSON check on both the client side and the server side. I check on both sides. So this is redundant. But client side, if you want to check it, that's great. But server side is necessity. We have to check. Okay. So I'm still going to leave it here. That's fine. I'm just basically not going to check it. I just directly communicate with the server. Okay, I think that's the only thing I need to worry about. And the other thing I need to check is I actually tweak the hw3 location intentionally. I'm going to change it back. You see that I intentionally misspell one of the keyword to longitude. So I'm actually going to remove. So now this is go back to the original state because I want to trigger the system to generate the exception, okay? All right, so now I have every pieces, I can actually try to compile. Okay, I don't need to compile the client, that's good. Okay, so let's try to run this. If I run the server on this side, and I run the client on this side, okay, so now I'm actually doing hw3 ref3 client, hw3 location, JSON hw3 question 01 JSON. If I run this, I'm actually getting the success, right? This was produced in personal record, personal time GPS record. That's actually representing the remote return is success. And this is supposed to be the output I'm getting, okay? And from the server side, yes, you're actually getting whatever you're getting, okay? This is client side and server side. Okay, this is supposed to work according to homework assignment number 3, ref 3. Okay, let's actually try to tweak it. So I'm actually going to modify the location 1 JSON. So if I do long, like what I did earlier, I add a bunch of T. So essentially I lost. I have a typo or I actually have some kind of error such that I didn't produce exactly the format as was expected by the GPS object. I don't have that. So let's save it. Okay, now I'm actually going to run it. Okay, so okay, this is because I didn't run the server, not because the code is down. Oh yeah, already. Okay. No, this is actually bad. Let me actually tell you what happened. So remember, I run the client. Let's look at this again. When you run this, the first time when you actually submit the upload, because when you upload, you have a mistake. So what happened is that on the server side, the first thing you're receiving, this, by the way, this is what you get from the client. You can see here, you see this attribute is what we intentionally changed to be misspelling. But the server program or whatever the JSON or GPS DD is expecting that you have a key value pair, which the key should be longitude, but you don't have that. That's why it's actually having a condition. So what happened is it will generate the exception. It will generate the exception. I will show you where that exception was generated. But then when you generate, I didn't provide the server side as the hw3 ref3. I didn't provide a try clause, try to catch it. So it will have this one basically say, hey, I'm going to terminating because why? Because I actually have an uncaught exception of the type ecs36b exception. So somebody generate an ecs36b exception, and I'm not ready to catch it. So basically, I'm done. So the server quit after this. So basically, if you have an exception in C++, you didn't handle it correctly, your server crash immediately. When your server crash immediately means the server is not there. So then subsequently, when the client want to make the second call, which is the question, remember the ref3 program, first is going to call upload, the second is going to call question. So when you try to get the question, you realize, okay, the client connector error saying that, well, this could not connect to this. Why? Because the server already crashed. Okay, so the one single exception, if you don't handle correctly, the server side is done, the client side realize, oh, I'm actually in trouble. Okay, I cannot connect. So this happened today a lot in terms of client server application. If there's a certain kind of mismatch, that sometimes server is actually suddenly disappear for a few seconds. I mean, obviously, if you have a good server architecture, it got crashed, but it will restart another instance, so it can handle subsequent, but there will be a glitch in the service. That's why sometimes you use today's mobile apps or remote application, you will have a short amount of time that's unavailable. Okay, so now I'm actually going to do two things. First, I want to tell you, I want to do two things. The first, I want to tell you where was the exception generated. Okay, we need to realize that when you have this, that means there must be some exception that was generated in the code. It was not being caught properly. And the second way is, well, how to fix it such that the exception really be able to be handled properly, will be able to have this server and continue to run as we expect, as we hopefully expect. Okay, so let's first look at what is the exception generated. By the way, any question up to this moment? Let's look at this. And let's first look at the server, because this is obviously in the server side. It's a server crash of this exceptional handling. So we know it's in upload. And I can tell you that it is actually within this line of code. It's actually in the code called JSON to object, okay? Remember I said, sorry, I was having an allergy over the weekend. Excuse me. I better wear my mouth mask, yeah. Okay, so a major difference between C++ object and JSON object is that C++ object, the compiler will check whether the code associated with the object, whether they're following the same kind of style. So C++ is mostly rely on compiler to check whether your object is well-formed. Well, however, JSON is I would say, an interpreter type of concept. So therefore, JSON object, you need to check online in your code at runtime. It's not going to, compiler is not going to help you to check the JSON. And so that's why in the client code, we have a lot of things we did to check, and such that we make sure the client won't crash the server. Okay, that's how we initially have the code set up in hardware assignment number 3, ref3. So in hardware assignment number 3, by the way, the reference code, that's a good practice. that the client is actually checking everything, so it won't send a EO form, the JSON, to the server to crash it, and such that nobody can access to that. That's a good habit, but that's not good enough. So within the server side, I actually will do a check, but the concept is called JSON to object. So JSON to object is how do I bridge the gap between the JSON's interpreter-based concept to the compiler-based concept of C++ object. So JSON to object is essentially how do I convert a JSON object to a C++ object. Okay, that's what JSON to object is doing. And it's actually very useful in a lot of applications if you can do this kind of conversion. So I can tell you that within this process, if you realize any of the key value pair you're expecting and you don't have that, JSON to object is going to throw. Okay, so let's take a look at the JSON to object. But also here, you look at this is what? PTGR PTR. PTGR PTR, which is a personal time GPS record. So let's actually look at that code over there. Okay, so the function, let me actually just include the okay, so this call PTGR PTR pointing to the JSON to object is this function that's actually going to be called JSON to object. Okay, so this call is actually coming over here. Okay, inside here you will see, okay, now I'm going to make it. Inside here, you will start seeing all the exception stuff. I'm not going to explain right now because my goal is not try to explain this yet. This is very important, but I will do it later. Right now, my first goal is trying to find out where that code is, where that code generated the error. Okay, so let's actually start look at any statement with throw. So you can see here, I have a throw. Okay, I have a throw statement inside here, essentially saying that, well, if this pointer is null, I'm going to throw it. And by the way, what kind of exception I'm throwing? I'm actually throwing ecs36b exception. Okay, I'm throwing that. And then there is another thing I'm checking whether you have this or not, I'm going to throw. And then I actually check whether you have identity, because a personal time GPS record need to have identity. So another thing, I'm checking the identity. Whenever I check the identity, I actually eventually, will I throw, by the way? Is null. Oh, I didn't throw at this point, right? Okay, here I didn't throw, but I will explain to you what I'm doing here. I'm actually just push back to a routine. And over here, I'm actually going to try something, and then I actually have another exception over here. And I have another one because I'm expecting another key value pair called traces. And over here, you can see a similar structure of the code, which at the end I didn't throw, but instead I actually have this push something to the back. Okay, and this part is something which I want to tell you. So up to this point, the code already know that it has identity. It has a traces. So now I need to go into the traces to handle each of the element in the array, which each of the element is a GPS location and a timestamp. That was the upload we're doing with homework 2 and homework 3. So inside here, I have a routine called JSON to object. to handle that particular record. So this is a time location, okay? And this one, you see that this one is actually catched by the try. I actually already have this by the try. And the try is over here. And in the try routine, I didn't throw anything. I just accumulate. Remember I said sometimes this is actually correspond to, sorry, I'm going to show you this figure again. Remember what I did is I show you that you try to collect the information about exception. You kind of collect at the end, you're going to throw something. Okay, so you can see that at the beginning, when I have certain arrow, I know that this arrow is too ridiculous. I have to throw immediately. But in the code over here, that now I'm actually realize it has at least a valid pointer, it has a valid structure. So now I'm actually going to try to parse the whole JSON. And eventually, you see at the end, I actually throw the whole thing. So I'm accumulate all the information. The E object I actually show you has been accumulated in the function called LV exception pointer. So I'm actually throw the whole thing at the end. Okay, but the thing is that right now we'll come back to this architecture why we're doing this. But now we're actually in this point. At this point, that we have a try, but inside here you see that we're calling JSON to object again. So we have the first JSON to object is the class personal time GPS record. But each of the personal time GPS record has an array of time location object. So now I'm actually going to go one level down to the JSON to object. So Control 2 to go to time location .cpp. Over here, I have a JSON to object again. So this part, I'm actually going down. So it's essentially, let me actually go back to here to tell you what I just showed you. How to generate. I'm actually getting from hw3ref3 server.cpp. And then we drill down to personal time GPS record.cpp. And then, by the way, this one is JSON to object. The function is JSON to object here. Okay. And then is actually going to call the next one is time location.cpp. Okay. So now we're in this level. Now the code, the structure, by the way, if you look at the code, the structure of the code is almost identical, but except the where, which, how, and what. Those information we want to include it is actually going to be customized depending on where the code is. For example, that this code, the where I'm going to put this particular exception was generated by time location. Okay, by time location. And let me just tell you, just compare the previous one. If you go to personal, CPP, and if you look at this code here, the location where is ecs36b arrow JSON to object personal time GPS record. So I'm actually, the exception encoded the where information according to which class the code was generated. Okay, so now we're moving one level down. So later you will see when you actually look at the exceptional information, you will be able to tell exactly where is coming from by the program. So now we're going to time location.cpp. Okay, it's the same structure, except the information I put it there somewhat different, especially the where part about the code. Okay, and then we have a location. So we just look at the location because the time we didn't tweak it. just the location. So when you have the location, if everything looks okay, then I'm actually going to do this. You see that? What I did is this location, JSON to object with the location. And what is this location? This location is GPSDD. If you look at Control X2, time, location, .h. So what is the type of location? The location is GPSDD, okay? So now this particular part of code, JSON to object, it still have a try and catch, those kind of thing, is actually going to pass their control to the next level, which is GPS.cpp. It's still JSON to object, okay? It's the same function, but we actually call it 3 times. So the personal time GPS record.cpp JSON to object will call time location version of JSON to object. Then it will call GPS.cpp's JSON to object. So now let's actually take a look at this part. Finally, we get to GPS.cpp. If you search for JSON to object, okay, it's still the same kind of code. Still the same kind of code, except the where now it says, if you look at this, the where, it says ecs36b arrow JSON to object GPSDD. Okay, so now you see that the code has been encoded differently at each of the level. This is a JSON to object. And then essentially what we're doing, this part is still doing the same thing. If you look at the code, it's really similar. The structure is really, really similar. So if you understand one, you should be able to understand every file in this. But of course, you have to kind of mentally put it together. So, okay, so now I have to do the latitude. Latitude is okay, everything is fine. But the trouble is the longitude. Remember, we modified the longitude. So I expect the code I showed you earlier, it will fail this particular test. Because why? Because the JSON we modify, if you remember that the JSON we modify is, it has the first element has a latitude and has a longitude. And I intentionally add a few extra character which no longer match with this particular piece of code here. Okay. So therefore, you're going to trigger this part of code. So let's actually look at what this part of code is doing. So, okay, so basically the first 4 lines, I'm not going to explain too much, but except you can see that the where code is actually encoded as GPSDD. And which string is actually say longitude. It basically say, hey, I'm in GPSDD, you're supposed to have attribute longitude, and you don't have it. That's why these 2 information give us enough information that we know exactly what went wrong in processing of this part of JSON. And then it will check if it's a null. I said, well, key missing, because it's a null. It's not there are 2 conditions I'm checking, whether the data type is correct. You see that the first one is null, the second one is double. And then if it's just missing, I'm going to post a message saying that JSON key missing. But if you're actually providing a data type that's not double, I'm going to report that, hey, this is an error JSON key type mismatch. Okay, so I'm going to push it, and then eventually I'm going to throw this. Okay, so I'm going to throw this from GPS. So, okay, now let's actually go back to this list. So this is, again, JSON to object, and is going to throw something, right? I just show you with the modified home location is going to throw. Okay, for the interest of time, this throw is going to is going to caught by time location dot cpp. Let me actually show you where that code is. So now we're going back. So remember, this is the location we call this function, right? And remember this one, I know, you see that this is nicely done because I have the try and I have a catch, ecs36b exception. So, okay, so this is basically being caught nicely by this piece of code, okay? So after we call it, you see what I'm doing? I actually do some extra encoding. And after I kind of getting all the information at the end, I actually throw again. Okay. So essentially what I did here is I caught, but at the end, I throw again. Okay. So I throw again. Now I throw it. Now the time location habit. So the next level is a personal time GPS record. So let's actually go back to the code. It will be caught by, I will just say PTGR, okay? PTGR.cpp. And again, it's actually going to do some processing. And at the end, it's going to throw again. So let's actually go back to the code. Okay, over here, where's my, hold on. Where's my code? Oh, here's the code, because here is the time location data. I have the array is trying to get everything one out of here. And then I actually catch. I basically encode a lot of things. And then at the end, I throw again. Okay, so now we're actually going back to here. And then finally, after throw, I have to go back to hw3ref3 server.cpp. Upload. Okay, I'm here. Okay, this is the place which I actually have the code. What's the problem? I mean, this was a problem in the code I released for homework assignment number 3, ref3, is that I didn't have this try and catch clause to protect this line in the middle is PTGR pointer to JSON to object. And therefore, because of that, now the exception throughout and there is nothing catching. By the way, let's actually try to do another thing, try to prove our theory. If I do try, and then I do, let's see, maybe I'm wrong again. Let me just see, catch. If I say std exception, I'm just curious. E. I just do this, okay. Throw catch with an exception and just do nothing. Okay, I'm just catch it and then do nothing. Let's see what happens. So let's try to run the server side and run the client side. Okay, you see that? I put the base it will still say, oh, this is something different. I'm actually kind of, if I catch this with a standard exception, I got a segmentation fault. This might or might not be to do with the exceptional handling, but let me do something else. Oh, that's interesting. I might be wrong when I interpret something earlier. STD. Okay, so if I do this, I said print. I caught a STD exception, \n. After this, I would just say exit -1. Okay. I just want to see if I throw a ecs36b exception, can I use a base class to catch it? Apparently, I still could, but just behavior is somewhat unpredictable. So let me try to make it. And I'm going to throw this. Okay, so you see, okay, I can actually still catch it. So I was wrong. I was actually wrong. I'm sorry about this. Just go back to the PowerPoint. Okay, I have to correct myself. That's embarrassing, but that's okay. That always happened to me. So here is, so if you throw exception, wait a minute. Oh, I see. Okay, this is okay, right? I throw ecs36b exception. I can call with exception. Okay, this is okay. So I'm not actually prove it. This one is okay. Okay, it's prove it, this okay, but the behavior might be unpredictable. The behavior might be unpredictable. Okay, so that's what we did. Okay, so I think I'm okay. I'm always, by the way, even for me, I programmed for so many times, it's still confused to me about the space and derived in under the context of exceptional handling. It's always confusing. Okay, all right, so that's good. All right, so let's come back. So now I'm happy. Let me go back to this one. Okay, so now we look at this piece of code. Now let me try to get rid of this. This is just a testing code. So now I'm actually going to add the correct fix. Okay, so hopefully what I just show you in the past, whatever, 20 minutes, was try to show you where that exceptional came from. And the root cause of the problem is because this exception potentially generated by JSON2 object, it was original from GPS DD, and then pass on to time location, and then pass on to PTGR, and then pass on supposed to hw3 server. And hw3 server couldn't be able to handle that because it failed to include the try clause. If you run this experiment on exactly the original hw3ref3 server and client, you will see exactly the same error. So now let's actually try to look at what's the proper way to do it. So I get rid of this try. Okay, so first let me quickly go through what's happening. So now I provide a try clause over here, and I try to catch it with ecs36b exception. And inside the routine, So what I'm actually first print out is the status is actually, I actually caught, because now, remember, we're doing remote procedural call. So I need to pass on this exception information to the client to make sure the client realize what kind of things that the mistake the client program made in terms of deliver the JSON. So I have to pass this information to the client. So I said status, I said ecs36b exceptional caught, but you can put anything you want. Okay, by the way, this one is just informational. The status is just informational to tell the client whatever you decide. This is a protocol between client and server. But the most important thing is the exception itself. The exception itself, I actually put exception JV. And what is exception JV? Is actually, so exception JV is produced this one. So what is E? E is the exception object. So the ecs36b exception object has a program called dump to JSON. So essentially, I'm dumping all the information that within that exception. And what is that exception object? The exception object is accumulating all the exception conditions when they try to handle the whole request from the client. So basically, I dump everything into a JSON format, and I actually return the result exceptions. I actually include the exception JV, and then I just say return. So if you look at the code, it's not that hard to do exception. The only thing you know is that you need to do a conversion. You need to convert the C++ exception back to the JSON representation, and then send it back to the client. Okay, so let's actually try to see if I do this, what's happening. Yes, I think that's everything I need to worry about. Okay, so now let's try to run server again. And now let's try to run the client. Okay, so now you can see that the client, if you look at the server side basically receive it and then it basically respond. But now since the upload failed, so when you do the question, it's actually going to give you not a good result because you don't have anything. But look at the exception. So this is the one that we add a code, just generate. Let's look at this piece of code. So it says ecs36b exception call. That's whatever string you want to put. But the most important is exceptions. And under exception, we have a ecs36b exception. And how many is actually counted by one? There is only one exception I detect. And within that exception, how is normal? What is JSON value key missing? Remember, it missed longitude. And it says where is actually JSON object, sorry. What did I do? Oh, I'm going to do here. Okay, let's look at here. So look at this, how is normal? I mean, we can change that, but it's not normal, but whatever string I put it there, normal. So it's a key missing because I missed longitude. What's the class? Is class under GPSDD. And what's the particular attribute I'm looking at is longitude. So by this what, where, and which, you know the original JSON must have some mistake about longitude. And that longitude must be misspelling because it says key missing. And the code that's actually reflect to that is GPSDD. So this actually give a lot of information to the client for them to try to fix whatever the input they have. Okay, let's try to do something else. Let me modify this again. So I come here, I fix this. Okay, I fixed the longitude, that's good. But I actually changed this to a string instead of a double. In JSON, if I put a double quote, both it's a string. Okay, so now if I do this, so now you see that I'm still getting the exception, but the what is different. So where and which is still says is GPS DD. The attribute is longitude, but now the reason is different. It says the key value type mismatch. Okay, so now you know that, okay, that's the problem because your key value type is mismatched. So you have to go back. Let me just do this. So that's the problem because I actually make it to this. Okay, so let me do one thing. I'm actually going to help you to show the other one. But I want to CP hw3 location 01.json to hw3 location 1.keep. I want to keep this way. Okay. So now I want to change two things. I want to change the longitude to TTT. So I change that, but I also change the time. I get rid of the string. I change this to 1.2, a number. Okay, so now I'm actually going to run this program. So now you see I have a two exception. Now you see the count is 2. Because I actually have a 2 arrow in the JSON I just passed, you can see that they're actually detected in 2 different classes. The first one is still key missing. That is a longitude, which is under GPS DD. But the second one is actually in a different place. It says key value type mismatch because it's expecting a string and we're giving them a number, which basically also the type is different. The type is in class JV time, and the attribute is time. Okay, so you can see that when you use this system of exceptional handling, this is just like this one. Sorry. This is just like this one. So F1 is related to JSON to object that's defined in GPSDB. And F2 is corresponding to the JSON to object that under JV time. The result get aggregate somewhere in the, by the way, the upper should be time location because time location is aggregate all this information. And eventually it pass all this to the upper level, which is either is PT GR or is actually the hw3ref3 server.cpp. And with this, you can actually just gather the information very quickly, understand how the output is actually different than expected. So now the client program need to be automatically look at the exception and decide what's the proper way to handle it. Maybe this involves human user, but maybe a lot of time the program need to have this robustness to detect some kind of like a mismatch or the type mismatch, those kind of errors they can handle. So this makes the programming a little bit different. So the programming emphasis is from processing the correct data, shift to how to detect all kind of error and decide how to fix it. Okay, so that's kind of taking the path from a simple programming to how do you do robust programming when the system itself could make error here and there. Okay. Okay, so now I want to, I talk a lot about this. Any question about this code? And before I talk even more about this. Any question? Okay, so by the way, in homework assignment number 4, what you need to do is you need to develop a client program and interact with the server program. And the server is going to send you back the information looks like this. And your program needs to automatically decide how to fix the error, if it's a fixable. But of course, I will give you what kind of error that's actually going to potentially show up. So you can actually make sure your program will be able to handle that error. And what we're going to grade your homework, this time I want to kind of help the TA a little bit. So TA don't need to worry about that. At some time, I'm going to run the server and you're going to produce the fix, the JSON. So initially you will get the JSON with error, but eventually you're going to send, your program going to send the correct JSON, which when you send the correct JSON, you will get a credit. So it's going to like a grade bar kind of thing. My server added together with homework 4. Okay, so just let you know that. Okay, so now I have a few minutes. I'm going to finish to tell you the detail about that. The place I kind of skipped. So I'm going to, let me go to GPS. Let's go to gps.cpp. Okay, so I'm going to go line by line with the GPS CPP, and then I'm going to go over to another one, time location. But this, I'm going to show you that the paradigm of the code is actually very similar. When you follow the same paradigm, you can actually be able to build the whole exceptional handling in a very large scale. So whenever I enter a piece of code, the first thing I have is that I actually want to have a pointer called exception info. And then I actually create an exceptional object. And this object is the one I'm going to throw at the end of the program. So if you see what happened in this slide, you see the F upper, I usually create an E object, exception object. At the end of the program, I throw. Okay, so essentially, when I write this code, I already prepared to do this. I'm actually going to accumulate a bunch of exceptions and try to throw at the end. Okay, so this 2 line is actually declared the variable I'm going to accumulate along the way, especially the ecs36b exception. So this is a pointer I'm going to throw. And let me just tell you at the end what at the end looks like. At the end, I'm just checking whether this exception pointer is actually 0 or not, because exception, inside the exception has a one of the array, which is accumulating all the information. If that array, the size is actually greater than 0, which is not equal to 0, then I'm going to throw that information over. Okay, so that's the exception. And one thing you will actually realize, I will actually talk about this if I have time today, is that when I throw these things, I'm actually throw this because earlier this one was new. So you need to have a delete. I do have a delete. It's actually defined in, by the way, the whole thing is defined in ecs36b exception. So I have a my destructor. You see that I actually have a routine to delete everything. And because of the structure of the exception, I have to create my own deletion in order to get rid of this using, I call it my destructor. Is the control, I have to do this my destructor. Okay, so let's actually go back now to see GPSDD. Okay, the first thing after I create the structure, so just to let you know, ecs36b exception is the one I'm going to accumulate. So let's look at first. Suppose you are going to, let's say the JSON to object is actually passing a pointer. By the way, it's passing a pointer to a JSON value. So the first thing I check, if you actually gave me a null value, you didn't pass anything, it's a null pointer. So I'm not going to handle this because there is no information. So guess what? I'm actually going to say where is still GPSDD because it's in GPS class. And the string is nothing to do with attribute, so the string is default. But then the what code, I put arrow null JSON pointer. So meaning that I'm encounter decision, exception, which the JSON pointer itself is a null. And then at the end, I actually push it and then I just throw. I mean, the reason I throw it right here is because if it's a null pointer, I cannot process the rest. Because if I process the rest, for example, the next one, I said ARG JSON is null. This one is going to give me segmentation fault. So that's why I cannot wait until later to throw. I have to throw it right away. Okay, so that's why here I actually throw it's a null pointer. Okay, so and then basically I said, well, now I'm going to handle the GPS. It needs to be an object. So over here, this is not an object. If it's not an object, I also don't have any reason to continue. So I just basically throw the exception. And look at the code. You say if it's a null, I would say key missing or key type value is different because it's not an object. Okay, and then I'm actually going to handle latitude. We already see that latitude is the same as longitude. It has this where, but always a little bit different about exactly the type of the arrow we need to include it. But this time you see I didn't throw immediately. Did I throw this one immediately? Yes, I throw this immediately because it's not an object I have to throw. But latitude, I say, okay, if you have an exception, I can live with it. I want to see what other things you have. So I didn't throw, I just accumulate the information. By the way, how do I accumulate? I actually accumulate through LV exceptional pointer, info pointer, which is I kind of accumulate this called EI pointer. Let me tell you what is EI pointer. See, I use a lot of EI pointer. Now you should appreciate what your ecs36a teacher told you about pointer. So I actually have the EI pointer is exceptional information. It includes where, which, how, and what. So EI pointer is the place I'm encoding all the information. And after I encode all the information, I actually push it back. I push into this LV exception info vector. So info vector is an array of the EI pointer. So I'm actually accumulating all the exception into an array. And if you look at the structure of the code oh, by the way, this code is everything is normal. If everything is normal, this is the line of code it will ask you. Because you have latitude, the type is correct, then you can say JSON pointer latitude dot s double and assign to this latitude. So you see that there's a lot of checking before you can actually do this. If you assume everything is correct, by the way, if you assume people will give you a perfectly correct JSON, in fact, the first line of your code should be this line. So we haven't went through the whole process, just one line of code, okay? And again, you actually do the same thing for longitude. And again, this is the one line of code. By the way, the first version of JSON to object I wrote, this probably 5 or 6 years ago, literally only 2 lines of code without any exceptional handling. So that's why I'm telling you that over time, when I really want to develop a program that's actually going to be robust, handling all this various situations, you realize proportionally, the majority of your code is not related to the handling of the correct input. Most of the code is actually handling the error, unexpected, but that's actually real life. Okay, real programmer, you have to do that. And then at the end, this is a place we say that if I detect the LV exception pointer info vector, the size is not equal to 0, means that there is at least one exception being accumulated, then I'm going to throw it. If it's not, I just return. If everything is okay, then I don't throw anything. Okay, so when this happened, I have, okay, minus 1 minute. So I think I will continue this because I still have a few things I want to handle. Okay, all right. If you have any question, let me know. We can go to my office hour this afternoon.